Static electricity helps geckos get a grip. The amazing ability of some geckos to scale smooth walls and cling to ceilings could be primarily a result of contact electrification. That is the claim of researchers at the University of Waterloo in Canada, who have made a new study of the electrostatic interactions between the lizard's feet and two different surfaces. Their conclusion contrasts with conventional thinking, which attributes the stickiness of gecko feet to van der Waals forces. The exceptional climbing ability displayed by many geckos comes from their specially adapted toe pads. Each pad is covered in layers of microscopic hair-like structures that split into smaller, spatula-shaped tips. Being so small, the tips can get close to the surfaces on which the geckos walk, forming an intimate contact. Each setter contributes only a tiny attraction, but together they produce a combined adhesive force of about 10 newtons for each foot, which allows geckos to hang from a ceiling by a single limb. Letting go is not a problem because the adhesive effect is directional, allowing a gecko to detach by simply reorientating its foot. According to conventional theory, the attraction is a result of van der Waals interactions. These are weak dipole-dipole forces that act between adjacent atoms and molecules as a result of shifting electron concentrations. In their new study, Alexander Penlidis and colleagues looked at how contact electrification could contribute to gecko adhesion. This effect occurs when two materials touch and exchange electric charges. The result is a net negative electrostatic charge on one material and a positive charge on the other, which causes an attractive force between the two. To test whether these interactions could be contributing to the adhesive abilities of geckos, the researchers measured the electric charges and adhesive forces generated when gecko toe pads were stuck on two insulating polymer surfaces, one of Teflon AF and one of polydimethyl siloxane. In both cases, on contact the gecko's toe pads became positively charged and the surfaces negatively charged. Furthermore, the adhesion strength correlated with the magnitude of the electrostatic charge that was generated, despite having a lesser potential for generating van der Waals forces. Teflon AF was seen to have a much stronger adhesion than the other substrate. This, say the researchers, suggests that contact electrification plays a major role in gecko adhesion. The finding could overturn 80 years of conventional wisdom that electrostatic interactions are not involved in gecko adhesion. Penlidis and colleagues believe this dismissal can be traced back to an experiment described in 1934 by a German scientist. Ionized air, which would neutralize electrostatic interactions, was blown towards a gecko clinging to a metal's surface and had no effect on its ability to hang on. Penlidis and colleagues explain that this German's observations are consistent with their conclusion because the contact between setter and substrate is so close that ionized molecules in the air would not be able to get between the two to neutralize the interaction. While contact electrification could play an important role in a gecko's ability to scale smooth walls, it is not clear whether the force is any help on rougher surfaces.
所谓的帮就是推广书呢，我到中国好几个地方去讲演，给一些大学生什么的就是讲一讲我最爱讲的这个问题，怎么学语言。我想对这个语言学习，我认为有3个大因素。第一呢，绝对最重要的是态度。
In 2002, Keller Autumn of Lewis and Clark College in Oregon was the first to observe the van der Waals interaction in gecko feet. Commenting on this latest research, he says,
推动中美合作伙伴关系不断向前发展，美国总统奥巴马会见王岐山和代表。5月9日，美国总统奥巴马在华盛顿白宫椭圆形办公室。
However, Autumn is not convinced that electrostatic forces are dominant, pointing out that this conclusion is not supported by the results of the study.
王岐山首先转达了胡锦涛主席致奥巴马总统的口信。胡锦涛在口信中表示，自今年1月对美国进行常务国事访问以来，中美元首达成的努力建设相互尊重。
Some experts disagree with his findings of the study, so further investigation is needed.